Hi and welcome to the 2018 paper 2 of the Junior Cert Higher Level. This is question 3 we're starting on now. And as usual, if you want a copy of these notes, just send me an email at shanetroy@gmail.com and the email address should be in the description below. So I suggest as always to try just like pause this question, have a go yourself. Okay, if you're struggling, keep going and check your answer and see if you can get a strategy start. This is fairly handy, this part A, but let's get stuck in. A solid cone has a radius of 5 centimeters and a vertical height of 12 centimeters, shown in the diagram below. Okay, I'm not sure why they're saying solid, but we'll go with it. It says part A, use the theorem of Pythagoras. Now I've written it out here. Okay, I've taken it directly from the maths tables, the screen print. I personally always go h squared hypotenuse squared, but that's just how I was raised. It's all the same thing. So the longest side squared equals the sum of the squares of the other two sides. Now, you might argue, well, why is that affecting a cone? And it can be hard to see because we're looking at this in a three-dimensional shape. But if I was to look at this like head-on like this, okay, I'll end up with this shape. Now, well, that represents a triangle. Okay, I'm more focused with the line coming down the middle. Okay, it should be straight, but whatever. And that creates a right angle with the base. Now, that's two right angle triangles either side. As you see there, this one is 12 here on this side here, and the base here is 5. So the side across from that right angle, that's your hypotenuse, okay, or the formula they call it C. So I'm basically being asked to look at what's the hypotenuse of that right angle triangle. And once you make that realization, it's easy peasy, okay. Pythagoras. Okay, apologies for that. I'm just so popular on my phone, won't stop ringing. I wish. Anyway, so we were talking about how this is a right angle triangle. Now, most students find Pythagoras fairly handy. There's only 3 parts to it. If you have 2, you can use your algebra, whatever, to find the missing part, missing side. Okay, just get stuck in. So the formula written out there, okay, and I've wrote out the 3 things. And so the hypotenuse, or the longest side, I'm just calling that L based on the diagram. The one side is 12, the other side is 5. Okay, now I substitute my numbers into the formula. Okay, now I've done it in brackets here, but don't necessarily need it because nothing won't be affected. But just be careful if you are a negative number going in. Like if I write negative 12 squared like this and put it through the calculator, it'll probably give you an answer of minus 144, which would be incorrect. Okay, you can't have, a negative number from squaring doesn't happen. So if you put it in brackets, it tells the calculator to calculate minus 12 times minus 12, which is plus 144. Now you'd probably see if you had a minus number here and a minus number here, you'd probably just ignore it, knowing that like this is the length, you can't have negative numbers. But you also might not. It's a very common mistake. So if we go left to right now, okay, I can't remember the square here yet. Okay, but 12 squared you said is 144. 5 squared, 5 times 5 is 25. Do the maths there and add the sum. 144 and 25 is 169. Now, if you know your square and square roots, square root of 169 is going to be 13. So you're fairly sure you're on the right path. But the last little step of algebra is I want L, okay, not L squared. So the square needs to come across the equal. Okay, once something goes across the equal, changes to its opposite. The opposite of squaring is square rooting. Okay. So square root of 169, throw through the calculator, I come out with a round number, whole number, and it's 13. And the units there were in centimeters, so I reflect that in my answer. That's it. Okay. Now, putting this through the, lack of a better word, BS meter, like your hypotenuse should be the longest side. So is 13 longer than the other two sides, 12 and 5? It is. Okay. So there's nothing screaming at me that this is anything wrong. If I had a number here that was smaller than 12, say, something's gone wrong, because this should be the L here, the slant height, should be the longest side. And that's part A, and it was good 10 marks for that. Okay, so happy days. Part B here, a little bit harder. Now, still 10 marks on this one. Okay, and you won't know that obviously in the exam, but you're asked here to work out the total surface area of the cone and give your answer in centimeters squared, because the area is always in square units. And finally, when you're finished, just make sure you round that to 1 decimal place. I've taken a screen print in here of the maths tables, and you've got the cone and you have the formula here. Now A stands for curved surface area. Okay, V stands for volume. So make sure, even if you do know the formula, just you check them. It's the most common mistake, even from like the best of students. I've often seen so many things like a third pi r cubed times h, just mixing in two different formula. So just have it open. You're doing this each question on the right section, and just double check. Okay. So I'm looking here now at this shape, just to keep in mind that if I'm doing the total surface area, this is not just the curved surface area. I have the curvy part. Okay. So that part I'm focusing on there, and the base, which is just a circle. So the area of a circle is pi r squared. So I'm trying to get that across here with this infographic I just grabbed from Google. And they call it lateral surface area, the area around there, okay, plus the area of the base. You see that reflected here. And that's kind of your formula. Now, circumference is pi r, so 2 pi r. So a half of 2 pi r is 1 pi r. Okay, so that's where I got this here. Pi r. Now, L is the slant height. Okay, and they're calling it HS in this formula, so probably should have picked a better infographic in hindsight. So pi times the radius times the slant height. Now we know all them. Okay, we know the radius is 5. We know the slant height is 13. We just calculate that. And we know pi is putting on the calculator. I would avoid trying to use 3 pi 1 4 or 22 over 7. Just use the button on the calculator. That's what it's for. Now the second part of the shape is the base, which is just the area of a circle, which is pi r squared. Okay. Now again, it's the same r, okay, because it's the base of that cone. So I can put in pi times 5 to be squared. Now the whole thing basically can go on the calculator, okay, and you end up usually down here. You can change it from, in terms of pi, into decimal. You're going to get a long number, 0.74 something, something, something. Now we only want to one decimal place. So the only number that really matters there is the 4, okay. 4 is less than 5, so the number prior to it stays the same. You end up with a figure of 282.7 centimeters squared, and I can see nothing wrong with that, okay, in the sense that there's no number seems fine, okay, and we're done. Now, I've done it here in the middle just by doing it step by step, okay, working it down, but look, the calculator is there for a reason, okay, if you've programmed it right, and you've shown your steps, you just save time, okay, and more be less likely to be in error than our own, say, calculations. Now that's part B. I see nothing left to do there. Okay, so I'll move on. Now this part C is fairly tricky. Okay, this came up in the Leaving Cert ordinary level paper, something along these lines. So I put in this formula here. Didn't actually need to. Okay, the only formula I actually need is the circumference. Now the maths tables will call that length, L is equal to 2 pi r. I'm old school. It's circumference to me, so apologies if that seems to be confusing. So we have here now, nets are fairly new to me as well, okay, but a net is just the shape of something as when it's folded out completely, okay. But the net of this cone is made up of two parts. Fair enough, we get that. You have the circular base and a sector. Now, if you can imagine the sector here, if we kind of brought that together, okay, they would join up to be a cone. So if you imagine a cone there, okay, and you've kind of, let's go the whole way around, and you've just unfolded it, okay. That whole length there, around, then kind of the circle thing there, is that, okay. This bit here is this bit here. Okay, so that's your slant height, for lack of a better word, which we said was 13, I think, wasn't it? That's 13, okay. If we were to find the length of this thing here, okay, if you think about it, that's, as we said, it's just that circle unfolded. We know that, or we can calculate the length of that circle there, okay, and that's that part there, okay. So what is the radius of the circle? Okay, now, this particular circle, we were told, weren't we? Yeah, we're told it's 5. Let's go to the answer here, yeah. Okay, so the radius is 5. We were told that. Okay. Circumference of that is circumference equals, I've done it down here, 2 pi r. You're given 5. You know pi in the calculator. So put in 2 pi times 5 is the same thing as 31.41 in decimal. Rounding to one decimal place is 31.4, and the unit is centimeters. That's the circumference there. Fairly handy. Now, here's where the trick comes in. This can be very tricky if you don't be able to visualize this or in some way figure it out. But that R we said here, okay, the radius of the sector, which is a different shape, okay, comes from the slant height. So if I'm changing this circle to a cone, okay, that's the cone there spread out. So the slant height there of 13 is what we're talking about. Okay. So slant height equals 13. Now, what is the circumference of this sector? Now, if I knew that, I suppose I could. If I knew this angle here, I could get, I know this is 13. I could use 2 pi r times the amount of the full circle that this is representing. But I don't know that angle, so that won't work. But if I just kind of think it through, that circumference or that length there of the sector is the same as the full length around here. And we know what that is. It's 31.4. So it's the same. It's also 31.4. Now again, that is tricky. When the time that was asked to leave a certain ordering level, wasn't that well answered, you know? Even though it was a bit, well, actually not bit, it was a lot more straightforward than this particular question here. Now it's reflected in a 10D scale, okay, so you're hoping to get different parts, okay, and realistically, if you didn't catch the sector thing, getting one part right, you're probably in around the 6 or maybe the 8. I'd have to just go check the marking scheme to be sure. Anyway, that's part C of question 3. Okay, so apologies again for the interruption halfway through, and thank you and see you on question 4.